Hello, this is Ace Test Academy. My name is Peace, and please, if you haven't subscribed to this channel, please kindly do so and click on the notification button for more information when new videos are dropped. We'll be looking at 2023 WAEC Physics Practical, and this practical is in three sets. We have question 1, question 2, and question 3. And question 1 is mechanism, question 2 is also mechanism, while question 3 is electricity. So, firstly, I will look into question 1, its mechanism, but advise everyone in the exam during watching the video to answer question 1 and question 3. So the precaution, first, that's what first thing you are going to be asked. You are going to be asked or the precautions to be taken. So the first one, I avoided draughts. I ensure the mass did not touch or rest on the table. I avoided error due to parallax on the meter rule. Make sure you put it that on the meter rule. I noted error on the meter rule also. So notice that all these ones are in past tense. Avoided, ensured, noted, they are in past tense. So you have to put it in the past tense. In the past tense. Now, can be asked of equilibrium also. A body is said to be in equilibrium when the body as a whole either remain at rest or move in a straight line with constant speed. The body is either not rotating at all or is not rotating at a constant velocity. That's the definition you can give to it. Now you can be asked of that define resultant force. Resultant force is the single force which acting along will have the same effect in magnitude and direction as two or more forces acting together. You can also be asked to define the moment of force. The moment of force about a point is the product of force and the perpendicular distance from the point to the line of action of the force, or the moment of force about a point is the turning effect of the force about that point. You can also be asked for the principle of moment. The principle of moment states that if a body is in equilibrium, the sum of the clockwise moment about any point on a body is equal to the sum of anti-clockwise moment about the same point. You can also be asked for the condition of a rigid body to be in equilibrium, or they can say that the condition of a body when it is being acted upon by three Cloppenham forces or by Cloppenham forces. They can ask this in many ways. This is just the answer. The algebraic sum of the moment about any point is 0. The forces must be concurrent to meet at a point. The resultant of the force in a given direction must be 0. The force can be kept in magnitude and direction by the side of the triangular taken order. So you can just choose anyone. You can ask you to list 3 or 2. So I choose anyone. That's for given to you. So you can also ask for the definition of center of gravity. The center of gravity of a body is the point through which its resultant weight acts. It can also be defined like this. It's a point at which the entire weight of the body appears to be concentrated. You can also be asked for the definition of the moment of a couple. You have the definition of moment already. You can also be asked that one of a couple. Moment of a couple is the product of the force and the perpendicular distance between the line of action of the two forces. And also, you can be asked to explain how center of gravity, that after that definition, you can be asked that how the center of gravity affect the equilibrium of a body. So that means what they are asking is stability of objects, how it affect the equilibrium of a body. So that's stable equilibrium, unstable equilibrium, and neutral equilibrium. So a stable equilibrium, that it tends to return to its original position when slightly displaced, while that of unstable, it tends to move further away from its original position when slightly displaced. The one of neutral equilibrium, it tends to come to rest in its new position when slightly displaced, as e.g. a ball or a ball on a horizontal surface. So also effect of height of center of, I just want to add this one. I don't know if it's going to come out. And that's the effect of height of a center of gravity on stability of an object. The height of the center of gravity of a body above the ground level and with the base of the object affect the stability of object here. So guys, here is calculation, possible calculation mechanism. This is the only type of calculation that if they bring any calculation, it will be more than this type of calculation. That is the one of meter rule, and you'll be asked to calculate the weight of the meter or distance, anything like that. So let's look into this calculation. A body of mass 58 gram is suspended at 20 centimeter mark of a uniform meter rule. Here is a uniform meter rule that is from 0 to 100 centimeter. That's the uniform meter rule. Now if 6 centimeter is suspended at 20 centimeter mark, here is 20 centimeter. So I add what 58 gram here. The meter is adjusted on the pivot until it settled horizontally as 40 centimeter. Here is 40 centimeter. So That's where I had what I had the pivot, but this that's where it settles horizontally at first. So that's where the pivot would be. That's why I added the pivot here. So calculate the mass of the metal rule. Remember, the mass of the metal rule is what? The center of gravity of the metal rule. That's the center of gravity of the metal rule. So it must be at the what? Midpoint. Center of gravity is highest at the midpoint. So that's the midpoint. That's 50 centimeter. That's why I added the weight here. That's mass of the metal rule. So before I proceed, you notice anti-clockwise movement equal to clockwise movement, and movement is what? Movement is force multiplied by distance. That is, the force must be in Newton and distance in meter. So that's why I have to convert it. This here is 58 grams. So to I have to convert it to force. So before that, I need to change this one to this 58 gram to kilogram, because the mass must be in kilogram before you can multiply by 10 when you want to convert it to force. So that's 50 divided by 1000. That when we convert it to kilogram, we divide 58 divided by 1000. So then we multiply by 10. That's the acceleration due to gravity. That's how you get this 0.58 Newton. And concerning this also, you have to convert the centimeter to meter. That's 20 divided by what? 100. That's 0.2 meter. And also here, between 40 and 50, the time between 40 and 50 here is 10 centimeter. So we have to convert also this 10 to what? To meter by dividing it by 100. That's 0.1 meter. So let's proceed. We know that anti-clockwise movement equal to what? Clockwise movement. So here is the anti-clockwise movement, and here is the what? Clockwise. Let's just do like this. Like this is the clockwise movement. So that's 0.58, and at the clockwise on around this place, the clockwise, that is, it's curved like this. So that's 0.58 multiplied by the distance from this place to this place, that's 0.2 meter, equal to what? The mass, that's W, that's the mass we are looking for, multiplied by 0.1. So if we divide both sides by 0.1, if you calculate this, you are going to get 0.116 Newton. Remember, we are asked to calculate the mass of the metal, the mass, not the weight, not Newton. So we have to convert it back to gram. That is, the first thing you have to do, convert it back to kilogram by dividing it by 10. As if you divide this force by 10, divide this moment, this moment, the weight, first thing you have to do, divide by 10. So if you divide by 10, it's automatically converted to kilogram. So if you multiply by this 1000, that's, you've converted it back to gram. You just see, you are reversing it from this place back to this. So that's just it. That's 116 gram. So this question that's calculated that can be asked from this side.